This video is going to teach you how to balance redox reactions by the half reaction method. So on page 15 of the notes, this is your first example. First thing you need to do is take ions with the same element in it. So this is one reaction you're going to write down, and this, iron 2 to iron 3, is the other one. So balance them one at a time. So I'm going to start with the permanganate ion, and you're told in step 1, rule 1, divide the equation into half reactions. So this is my first one. Rule 2, balance all elements besides hydrogen and oxygen. Well, that would be manganese. There's one on the left, there's one on the right, so they're balanced. Moving to step 3, I balance oxygen by adding water to the appropriate side. So I have 4 oxygens here but none there, so I need to add 4 waters to this side. That's rule 3. Now moving to rule 4, balance hydrogens by adding hydronium ions. So I have 8 hydrogens here, so I'm going to add 8 protons, H plus ions there. That's rule 4. So at this point, notice all my atoms are balanced. 1 manganese, 4 oxygen, 4 oxygen, 8 hydrogen, 8 hydrogen. So the atoms are balanced. So rule 5 takes you to the next part of the equation. You have to balance the charge. Well, this is 8 plus, this is minus 1. That's a net of plus 7 for the reactant side. Then you have plus 2 plus 0 is a positive 2. And to balance the charge, you have to add electrons to the more positive side. That would be this one. How many electrons would I have to add to bring 7 into balance with 2? 5. So I add 5 electrons. Now I have 7 minus 5 is plus 2. And I'm balanced by charge. That's rule 5. So that half reaction is balanced. I'm done with it for now. So I'll move on to the next half reaction, which would be iron 2 to iron 3. Moving through the steps one at a time. We wrote the half reaction. 2, balance all elements besides hydrogen and oxygen. Iron is balanced. 1 iron, 1 iron. Then balance oxygens, don't have any, I get to skip that step. Balance hydrogens, don't have any, I get to skip that step. So now I just have to balance the charge. I have a plus 2 and a plus 3. 3 is more positive than 2, so I add 1 electron because 3 minus 1 is 2. So that half cell is balanced. At this point, I have to make electrons gained equal to electrons given off or lost. There's 5 here, 1 here, so if I take this equation and multiply it by 5, then I will indeed have 5 electrons that will end up canceling, which is what you want to do. You want the electrons gained equal to the electrons lost. Then you just add up your equations when you figure out what factor to multiply by. So at this point, we're going to bring down 8 hydrogen ion plus the permanganate ion. I'm not going to write the electrons because I know they cancel. So I go pick up my last reactant, which is iron 2 plus. Continuing on, oh, I skipped something. I have to multiply that by 5. So this is really going to end up 5, 5, 5 when I do that multiplication. So I need to put plus 5 iron 2, and that's going to give me a manganese 2 ion plus 5 iron 3 plus 4 waters. If I've done everything correctly, the atoms should balance the charge, so the last step is to check. So I have 8 hydrogens on the left. 4 times 2 is 8. Check. 1 manganese, 4 oxygen, 4 oxygen, 5 iron, 5 iron. Atoms are balanced. Check your charge. 8 minus 1 is 7. What do you have here? 7 plus 10 is 17. You have 2 plus 15 is 17. So atoms in charge balance. This is the answer to that example. You have balanced the redox reaction, and we say we've balanced it in acid because every time you have hydrogen ion, that's an acid. This is what means an acid when you produce those in solution. So this is balanced in acid. How would I change it if I want to balance in base will be the next thing I do. So I'm going to write up here, I'm going to start with what I got in acid. So you always balance as if in acid. And if you want it in base, you take your acid answer and change it to get it into base. That's the easiest way. Do not follow these instructions in these notes. Balance everything as if in acid. And I'm running out of room. Okay. Water. Okay. So if they had asked us to balance that reaction in acid, in base, we would do just what we did here, balancing it in acid. How do I convert it to base? We add the same number of hydroxide ions as hydrogen ions. And of course this is to both sides, right? What we do to one side of an equation, we have to do it to the other to keep it in balance. So I have 8 hydrogen ions, so I'm going to add 8 hydroxide ions to the left. Here's my reaction arrow. On this side, I also have to add 8 hydroxide ions. Then we're going to make, combine, let's say combine. Combine hydrogen ion and hydroxide ion to make, you guessed it, water. So 8 of those and 8 of those are going to now give me 8 water. Plus permanganate ion, plus 5 iron 2 ions going to manganese 2 ions, plus 5 iron 3, plus 4 water. And then we have to remember this didn't do anything, so I have to include it on this side to keep it in balance. What you notice now is you have water on the left and you have water on the right, so you can subtract 4 waters from both sides, and that's going to change 8 waters. 8 minus 4 leaves you with 4 waters, and this will be your answer in basic solution. So 4 waters plus the permanganate ion plus 5 iron 2 ions going to manganese 2 plus 5 iron 3 plus 8 hydroxides. And the key here is every time you see hydroxide ion, you know you are in basic solution. So we have gone from acid, this is balanced in acid. By doing these 2 simple steps, you have converted it to a reaction, redox reaction balanced in base. So that should help you finish your homework on balancing redox reactions. Follow the steps as I showed you in the video. Thank you.